So what you're seeing here, okay, is just the data from this previous chart, okay? So we took the total cost, and that is going to be this red line here. Then this dark red line down here is going to be your variable cost. Your fixed cost, you can see quantity is along the x-axis and dollars is along the y-axis, okay? If we were going to graph your fixed cost, this guy here, okay? So let's focus on this top graph first. Fixed cost, we talked about it in the last lecture, and that's how we knew what it was, right? It was the cost of that truck per day, $200. We will rarely ever see a fixed cost curve graphed again. Your author's just showing it to you, but it's not something that really is useful from this point on, is to know what a fixed cost curve is. It's a horizontal line at whatever the fixed cost is. But we don't need it to get that information on this graph. I can tell by looking at this graph that fixed cost is 200 because it's where my total cost curve starts. When I'm producing zero quantity, my total cost curve starts at 200. Well, if I'm producing nothing and I have a cost of 200, I know that's my fixed cost because my variable cost is going to go up for each unit produced. It's going to be that driver, right? So my variable cost curve is actually what's going to pull up my total cost curve from that point on. So my variable cost curve sits right here. This is just those numbers from that previous chart where we calculated variable cost, right? We've just graphed those points per unit, okay, for the units that we produced at that point, for those quantities. And then your total cost curve is gonna pretty much follow that same sort of trajectory as your variable cost curve is, because your variable is actually what's pulling your total up. Your fixed is flat. It's not going anywhere. It's your variable that pulls your total up, right? At any given point along your variable and total cost curves, if you take the perfectly vertical distance, vertical up and down, not diagonal, right? Perfectly vertical. I love this for a multiple choice question, okay? If you take the perfectly vertical distance between your variable cost curve and your total cost curve, it will always equal your fixed cost because it's variable plus fixed that gives you that total. So the vertical distance between variable and total is always fixed, okay? All right. Sorry, I'm having a terrible time with Zoom today, getting it to look like I want it to look. So I can't even get my chat box to come up. There it is. Okay. All right. Oh my God. Okay. So the following graph, the graph there at the bottom, is going to be your marginal cost curve. Now you can't put totals and marginals on the same graph. You just can't, right? You don't have the right numbers to graph them both on the same graph. Here we have total dollars, okay, for cost, and here we have sort of cost per unit. Again, marginals and totals can never go on the same graph. The numbers are just way too different to put on the same graph. And it's two totally different analyses, okay? But you can see your marginal cost, right? It started at 50, we went down to 33, bless you. We went down to 25, that was the lowest our marginal cost got, right? Previous graph, right? We went from 50 to 33 to 25, and then we headed back up again. So here we go, we're headed back up again, okay? So this is the beginning of a check mark, beginning of a check mark. Now we're looking at such a small operation that we never get to the actual tail of that check mark, but you'll see in larger operations we do, okay? If your marginal cost curve doesn't look like a check mark, you've done something wrong, okay? And that's a good double check for your worksheet. All right, now I am going to do a different share to give you the 7-2 PowerPoint. So here's the 7-2 PowerPoint, okay? And we'll continue on with the discussion. Sorry, guys. All right, let me try that again. All right, I think this is the one we want. All right, this is a 7-2. Couple new calculations that we're going to talk about when it comes to those costs is average costs. We talked about totals, we talked about marginal costs, and now we're going to talk about average. Average is easy. You've been doing averages since what, 3rd grade, something like that, right? And so this is just another way to look at that costing data. For those of you who are accounting majors, this is a lot of the costing you're going to do is average costing, okay? Because it's simple, it's straightforward, right? And so average variable cost is just that. Take your variable cost at some level of output and divide it by that output. And then take your variable cost at some other level of output and divide it by that output and plot those. And if you come up with your average variable cost at different output, different quantities of production, you can then graph those and you will come up with an average variable cost curve. It's going to become a really important part of our analysis too. You could calculate average fixed cost. A fixed cost divided by your output is going to give you your average. Okay, you could also graph that. We don't, but you could. Fixed cost is one of those things that we don't really graph too much because there's other easy ways to find it on the graph. And then average total cost. Take the total cost, okay, so your fixed plus your variable and divide it by your output, and you get your average total cost, or what we refer to as your ATC, your average total cost. All right, so let's create a relationship between average costs and marginal costs. There's a really strong relationship, and understanding that relationship, which you actually already do, will be very, very beneficial to you, okay? So I'm just gonna do a little example for you up here on the board on how you already know the relationship between marginals and averages, and then we'll go through this particular slide. So the marginals and averages I think you are most familiar with have to do with your GPA. And if you think back to your GPA, right, and how it's calculated, it has marginal components, that's your semester GPA, and then you have a total, and that's your overall average, right? That's your average. And so if you start out the first semester with a 3.4, and that's your only marginal number, then your total will also be a 3.4. Semester number 1. You get to semester number 2, and you get a 2.8. What's going to happen to the total? Your average. I shouldn't say your total. This is more like your average. What's going to happen to your GPA? You already know.
It's going to drop.
It's going to go down. Go ahead.
Oh, I was just saying it was going to drop.
It's going to drop. You already know that, right? And the same thing happens with cost, but this is just a really good analogy. You know it's going to drop because when your marginal is less than your average, it pulls your average down. When your marginal is less than your average, it pulls your average down. And that's the first statement on this PowerPoint. But it's speaking to costs and not GPAs. So this is going to pull you down to a 3.1, right? Now, if you have a 3.1 as your GPA, your marginal GPA, what's going to happen to your overall average? Stays the same, right? Stays the same. And then if you have a marginal that's greater than your average, it's going to do what? It's going to pull it up, okay? So when Same goes for costs. When your marginal cost is less than your average, it pulls down the average. When your marginal cost is greater than the average, it's going to pull up the average. So what ends up happening is we have these U-shaped cost curves. Your average variable cost and average total cost end up giving you these two U-shaped cost curves that end up being really important in the analysis. And they have a direct relationship to the marginal cost curve, which is that check mark we just talked about. Okay, so just bear with me because we're going to put this all on a graph here in a minute. Cost curves, average cost curves, total average cost curves, average variable cost curves are going to have that U shape because of that law of diminishing marginal returns. Because your production goes up and then down, your marginal production, your marginal returns go up and then down, your cost per unit goes down and then up because of that inverse relationship between those two things. Okay. As your returns go up, your cost per unit goes down. Okay. This is the chart that you are going to use to refer back to when you are doing the worksheet. This is almost identical to your worksheet, this chart right here. I'm going to give you quantity, that's a given, okay? I'm going to give you variable cost, that'll be a given, and then I'm going to give you fixed cost, which is not on here, but will be on the one that I give you, okay? We know that fixed cost is 200, just because this is a continuing example, but on your worksheet, I'll give you the dollar amount, right? And then you will add together variable plus fixed to give you total. All of your little equations on how to calculate your different columns are going to be up here, okay? And then you're going to calculate your marginal cost, which is the change in total cost. So as you go from producing 0 units to 2 units, because you employ 1 more unit of the resource, your total cost, you got 100. Divided by your change in quantity of 2, 100 divided by 2 gave you your marginal. We already did this, right? We already did this. And then I'm going to have you calculate your AVC, or your average variable cost, by taking your variable cost. In this case, 100 divided by 2, 200 divided by 5, 300 divided by 9. And I'm going to have you fill in the chart with your AVC, or average variable cost. This will be a U-shaped curve, so you should expect the numbers to go down and then go back up. Just like with your marginals, they go down and then they go back up. These go down and then they go back up. Your average total cost curve, you're going to take your total cost and divide it by the quantity. So 300 divided by 2 gives me 150. 400 divided by 5 gives me 80, so on and so forth. You should expect these to go down and then go back up. If your numbers do not go down and then go back up, you've calculated something wrong. And you need to go back and double check that, okay? That's gonna be your first double check when you're doing the worksheet that's due on Friday. Any questions about this? About this data, where I got the numbers from? Okay, should be pretty straightforward, and this has all your little calculations up at the top that will show you how to. I think they're in your worksheet too, but if they're not, this is where you can come back to, okay? Then the next thing I'm gonna ask you to do on your worksheet is I'm gonna ask you to graph these 3 curves. I'm gonna ask you to graph marginal cost. I'm gonna ask you to graph AVC, or average variable cost. And I'm gonna ask you to graph ATC, or average total cost. These are the 2 curves that you will see over and over and over again in this class for the next 3-4 chapters, okay? So these are the curves. All of this has been built up to this point right here, to generating the 3 curves that we need to do profit maximization analysis. So we sort of hit the pinnacle of chapter number 7 right here, okay? And so I'm gonna ask you to graph those. And all you're gonna do is take that data and you're gonna plot all those points and you're gonna connect them. This is the second part of your worksheet. The top half of the worksheet is you filling in that chart with all the numbers you've calculated. And the second part is you graphing those 3 curves that you can now generate due to those calculations. If your graph does not look like this, you've done something wrong. These 3 curves always have the same orientation to one another. Always the same orientation, okay? Your AVC and ATC, your average total cost and average variable cost curves, are always a general U-shaped curve. This just doesn't go out far enough for you to kind of see the whole U of that ATC. And then your marginal cost curve is always this check mark that intersects your AVC and your ATC. It always looks the same, or at least in the nice, typical examples that we're gonna see in this class, they're always gonna look the same, okay? So let's dig a little deeper here into these curves. So your average variable cost curve is always going to sit below your average total cost curve. Well, it's pretty obvious. It's average plus fixed that gives you total, so you would expect the total to be higher than the variable because the difference is the fixed, right? The vertical distance between ATC and AVC is average fixed cost. You don't graph average fixed costs because you really don't need it. But if you needed to find it, you would take the vertical distance between these 2 curves. Do you see how average fixed cost keeps getting smaller and smaller and smaller and smaller? That's because you're taking the same number, the same numerator, 200 in this case, and you're dividing it by a progressively larger and larger and larger number as you produce more and more and more in quantity. Sorry, you guys can't even see that. Like a 200. It's 200 divided by, you know, first 2 and then, you know, 12 and then 15 and then 100 or whatever, right? And so that's why your AFC or your average fixed cost gets smaller and smaller, and it's just the gap between those 2. Okay? You don't really need to know that, except if it comes up on a multiple choice question, okay? Because these are really the curves we need to do our most important analysis. Then you see how your marginal cost curve sort of starts low and then swoops up and intersects AVC and ATC and then continues upward. What do you think we can say? If you think about what we just talked about, the relationship between averages and marginals, what do you think these points of intersection represent? What could you say about those points? This is a beautiful multiple choice question. Mm-hmm.
It's intersecting through the very bottom of the curve.
Ah. That the intersection happens at the lowest point on the AVC and the ATC. We know this because we just said when the marginal, or that green yellowish line, right? As that sits below, let's start with your AVC, your average variable cost curve. As it sits below, it's pulling it down. So as that yellow line sits below the red line, it's pulling it down. But once it rises above, once your marginal is above your average, it begins to pull it up. So that point is the point of transition between when your marginal is lower than your average and then when your marginal is higher than your average. And so it's that pivot point on the curve where it hits its lowest point. And the same goes for your ATC. Your marginal cost curve hits your ATC at its lowest point, right? Because it's pulling it down when it sits below it. But when the point where it rises above it begins to go up. Any questions about that? It is really PowerPoints number 4 and 5 on this particular PowerPoint 7-2 that are going to walk you through your worksheet point by point by point. They should look very, very similar. If they don't, you did something wrong and you need to go back and check your numbers. Any questions? All right, I'll assume we're good. These are going to be those curves that I am just going to say your MC, your ATC, your AVC from this point forward. And we're going to talk about them constantly. So just make sure you have a general understanding of how they're derived and their relationship to one another. It's really what we're working on right now. Okay, so let's sort of switch from the short run to the long run. We talked about the difference between short run and long run in the last class period. The short run being the time period in which we have at least one fixed resource and therefore one fixed cost typically. And then there's this long run in which we have no fixed cost. The long run is just for planning. You actually don't operate in the long run. You have to really go from short run to short run, never really getting to the long run. I know this is highly conceptual, but if you think about it, if you have a 1-year lease on a building, you don't actually wait until the last day of the lease to start looking for a new lease and get it signed. You're actually going to do that beforehand in preparation of that day, the end of your current short run. You really want to go from short run into brand new short run with very little disruption in operations. So we only think about the long run when we are trying to plan for it. When we're like planning on what our next lease is going to look like, we get it signed. The minute we sign a lease for a new place, we've entered into a new short run. Because now we're locked in again. Right? But that's a good thing when it comes to operations, because if you don't have a lease on a building, you don't have an operation. I hope this makes sense. The long run is a planning horizon. That's all it is. The short runs, that's where we're operating, from short run to short run to short run. Okay? We know we can change anything in the long run. Firms have to plan for this. This is what managers do. Okay? So we have to understand, sort of refresh our memory about the concept of economies and diseconomies of scale before we can start to look at some of this planning we would do. Economies of scale, it's a condition. It's a condition we've actually already talked about. We just didn't use this terminology when we talked about it, okay? Economies of scale is a condition that we experience when average cost falls as we produce more and more of a good. So when you look at your average cost curves, it's the first half of it, essentially. When costs are going down, it's the first part of that curve till we hit that minimum point, right? Just happens to be the point of intersection with marginal costs. But we hit that minimum point, we are experiencing economies of scale. We are driving down average costs as we produce more. And then that changes. And then we begin to rise up again. Our cost curve takes that rise on the second half of it. Then we are experiencing something we call diseconomies of scale. The more we produce, the higher the costs become on average. On average, we're talking about average costs, okay? Economies of scale is a beautiful thing, right? And we maximize that right at the bottom of that cost curve. So economies of scale on the first half, diseconomies of scale on the second half. So just hold on to that as we go through and we talk about some of the planning that managers would do with these cost curves. Super, super important. Management level stuff. If you want to be a manager one day, this is something you're going to have to understand, is understanding costs and understanding economies and diseconomies of scale, okay? All right. Don't let this intimidate you. Let me sort of give you a backstory here. Here you're looking at 3 ATCs, average total cost curves. You're looking at, let's say, a small factory, a medium factory, and a large factory. Pretend for right now that those dashed lines are connected, okay? Pretend like they're not dashed lines until we get to the explanation, until we go through this example. But so you have a small factory ATC, you have a medium factory ATC, and you have a large factory ATC. So basically, how much would it cost to produce 1 unit of your good in a small, medium, or large factory, depending on the quantity, right? It is frequently that managers have to, in planning horizon, the long run, have to look at sort of estimated costs that they could have with different facilities and try and decide which facility they should start building now so that it can be ready a year from now, 2 years from now, 3 years from now. And so your accounting department has brought you these estimated costs associated with 3 different factories you could build. And now it's your job to decide which one's going to get built. Okay? So what would be the first thing? You see cost per unit on the y-axis, output along the x. If you were going to decide, if it was your job to decide which one of these factories was going to get built, what piece of information might you need to know before you could decide? What do you think? If your accountant laid this out in front of you and said, Mr. Manager, Miss Manager, please tell me which factory you would like us to start building.
How many you need to produce?
What is the quantity you're going to want to produce, right? That is the first thing I would want to know. I would want the marketing department, econ people, management people to get together and try and estimate what demand is going to be at that period in time. If it's going to take a year to build your factory, I want to know what they anticipate demand is going to be a year from now. Because then, looking at the data, I can tell you what the optimal factory to build is. Let's say, for instance, they tell us the quantity is Q prime, or Q with the little like apostrophe. I know by looking at my curves that I could actually build that quantity in 2 factories. I could build it in a small factory, or I could build it in a medium factory, because it actually hits both of those ATCs. Which factory do I actually want to build it in? Somebody at home, which factory do I want to build that in, the small or the medium? I can wait. Thank you, Jenny. Jenny says medium, she's right. Because as I start to work my way up from 0 cost per unit, and I begin to work myself up vertically along that dashed line, I hit the medium one first, which means the cost is lower on the medium one than it is in the small factory. That keeps my costs as low as possible if I build in a medium-sized factory. Thank you, Jenny, I appreciate it. Now let's say I'm told QA, or quantity A. Which factory would you build then? Thoughts, guesses? Devin says small. Any other guesses? Yeah, nobody's wrong. Dennis, it's small or medium. It depends, right? if I thought we were going to grow significantly after the factory was built, I'd probably go with the medium, because look at how much capacity, look at how much quantity I can produce out of that factory, right? There's a lot of growth that could happen in that factory. Not so much in the small factory, but it depends on your circumstances. If you don't expect to grow very much, you could do small, that would be fine, right? Either one is fine at QA. That's why these curves turned dashed at these points, is because they're no longer the cheapest cost at that quantity. So if you were on an exam and you were looking at something like this, right, you just want to work your way up from the bottom, from a cost of 0, and the curve you hit first is the curve you want to go with typically. I probably would not do like a point A or a point B like on an exam. But the right answer is it depends. You could go small or medium depending on your circumstances, okay? And as a manager, that's a decision you would have to make. All right, so we're gonna take this next level now. I don't want you to overthink this, but does it make sense that you would have more than 3 possible factory sizes you could build? It's kind of an endless number, isn't it? You change a factory by 10 square feet and it's potentially a new size factory, right? So you really have hundreds or thousands of options. Well, in reality, you'd probably look at several options, probably more than 3, probably more than small, medium, and large, right? You wouldn't run numbers on 1,000 different factory sizes or even 100, but you might on 10, just to give yourself a good picture of, you know, what the possibilities are. And so all we've done here, this is just a broader picture of what you just saw on the previous slide. On the previous slide, you just saw 3 little factories, which is probably this bottom piece here. It's probably like the 4, 5, and 6, okay? But this is probably what we would have initially run, is a lot more options. Perhaps 10 is a pretty reasonable number. Here's the takeaway from this slide. The takeaway from this slide is, can you imagine if there were actually 100 or even 1,000 cost curves sitting here together? That it would create this sort of curve on the outside. You can see it here. It's the dark red that you see. You can see it creates sort of this boundary line on the outside, which represents the lowest cost option, the lowest cost short run curve for every possible quantity of production that you could want to do. And we would call that boundary that sits on the outside like that your long run average cost curve. You're looking at these ATCs you're looking at, these are short run ATCs. These are one little factory that we might build right out into the future. That long run average cost curve gives you a picture of every factory you could possibly build and the lowest possible cost you could have, no matter what quantity you want to build. That's the takeaway. It's how do we get a long run average cost curve? How do we derive a long run average cost curve? Well, we put all the short runs together, right? And then we kind of trace the outside, and that's how we would get that. That's your takeaway. Don't overthink it, okay? I know it looks ugly. It's no big deal, okay? All right, I'm actually gonna skip this slide because I just wanna show you the picture. The only reason I am bringing up this curve is because some of you are gonna see it on your version of the homework question. It's not really something we're gonna spend a lot of time talking about. All this is saying is it is possible to have a cost curve that flattens at the bottom. Here's your economies of scale, right? This is sort of your typical U-shape. We've just sort of split it at the bottom and added what we call a constant average cost run in it over a certain number of quantity of units produced. Don't overthink this. Don't overthink this. But if you get something like this on your homework, here's just sort of a nice diagram that I think will help you answer the question. You experience economies of scale as the average cost per unit drops. Could level out. This would just be, I mean, probably depending on the type of industry that you're in or the type of market that you're in or your very particular good, you could experience this. You probably won't, but you could, okay? You would have some sort of a constant average cost run at the bottom where it flattens out. And then you would see your long run average cost begin to rise again as normal, as expected. But that would be your diseconomies of scale part. Again, if you end up with a question on your homework like this, come back to the slide. It'll probably help you. And this previous slide is just giving you a little bit more insight. So, but it won't be something that you see on your exam or anything like that, okay? And then that brings us to just one last thing that we have to consider. When you are developing average cost curves for planning, average cost curves to use in that long-term planning horizon, you probably have to do two sets. You probably have to do some planning on a plant by plant or location by location or store by store level to see how very particular units of your business, particular stores, particular locations, how they're doing in terms of cost. And then you have to do it on an overall firm or corporate level. Those are two totally different considerations. Many times we get announcements about how some big chain is going to close like 50 restaurants or 50 stores or something like that. It's because they've done the analysis on both ends. They've done a plant level or location level analysis and said, these costs aren't working for us. But overall, as a firm, as a corporation, as a company, our numbers look fine. But it's that little piece that just isn't working out for us and is actually kind of dragging us down as a corporation. We got to close that plant up. So as a manager, you want both sets of data because you have two sets of decisions you're going to need to make, right? Okay. This happens all the time in very, very, very large corporations. Any questions about any of that? That's chapter 7. It's manageable if you spend a little extra time going back and making sure that you understood everything that I said. The biggest takeaway here, by far, the biggest takeaway are these curves right here. That's really what you needed to get from this chapter, is understanding where costs come from, understanding how to break them down into pieces that we can use for analysis, and then how to graph them once you've done that. If you understand what you're going to do on the worksheet, if you understand how to calculate these numbers and then how to graph them, you're good. You're good for chapter 8.